Number 17. This is really interesting point, okay? It is too nice, right? Now only function f borrows like we gave you f prime and f double prime, okay? Just use it, okay? So like we're gonna talk about increasing, decreasing, and local maximum, local minimum with f prime. And we're gonna talk about concave up and down with f double prime, okay? So but keep that in mind. Like same thing with the previous problem, you must think about the domain, okay? So like, function f. What is that? It's all real number except x equal to 1, okay? Don't forget this point, okay? You must include this point like in the all the sign chart for f prime and f double prime, okay? And that's it. So now let's move to f prime. F prime given by x plus 2 square, x minus 7 over x minus 1 cubed, okay? To find critical number, we're going to set that equals 0. As I told you, fraction equals 0 means just numerator equals 0. So we have like 2 critical number, which is -2 and 7, okay? But keep that in mind, not only critical number, but we need partition number and 1. But this one must be like not included in your domain. So whenever we find partition number, you have to draw the sign chart, okay? There we go. -2 and 7, these are just strict line, but 1 must be broken and empty circle. Okay, now we have like 4 sections, okay? Less than -2, plug in -3 into my f prime, fully factorial, okay? Then square part is always positive, then -3 minus 7 is negative, and positive, which is positive. So f is increasing this group, okay? Between -2 and 1, maybe we can try to plug in 0, and positive, negative, negative, positive. Okay, and what about 1 to 7? Okay, maybe you can plug in 2, positive, negative, positive. So we have only 1 negative, which means f prime is negative. Okay, and bigger than 7. 10, positive, 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 all positive. That's okay. So we can answer the first part, okay? There we go. Increasing interval is from -infinity to -2, and -2, 1, and 7 to infinity, right? And decreasing interval is from 1 to 7, okay? Now we can talk about local maximum, local minimum, okay? But for this case, you have to be careful about your local maximum, okay? Like it looks like we have local maximum at x equal 1, but that's why but it is not. That's why I would love to use the broken line and empty circle, because that is undefined point, okay? Actually, there is a vertical asymptote, okay? So like, x equal to 1, there's no local maximum for this function, okay? But we have local minimum, okay? That's it. Does it make sense? Okay. So now it's time to talk about concavity, okay? To talk about concavity, we have to talk about a double prime. Like as I told you, this is given as well. 54 x plus 2 over x minus 1 to the 4. Then we'll do same thing. We're going to set that equals 0. Then we can easily figure out this is the critical number for f prime, double prime. Then, but keep that in mind. Not only this one, but we need the partition number. -2 and 1, but this one is not included, okay? So let me draw the sign chart. Okay. There we go. -2 is just strict line because that is in the domain, but 1 is out of domain. That's why we're going to use the broken line and empty circle. Now we have like 3 separate sections, okay? And we're going to plug in a number which is less than -2, maybe -3, okay? You don't have to worry about sign of denominator, okay? Because power is 4, okay? Negative 3 plus 2 is negative, okay? So f double prime negative. So f is concave downward, okay? Between negative 2 and 1, maybe 0, and it is positive. That's it, right? And then 1 to infinite, maybe 10, okay? That's definitely positive. And f is concave upward. That's it, right? When you compare with the sign chart of like a prime, it really makes sense, right? There we go. Now we can answer this guy, okay? Concave downward is from minus infinity to negative 2. Concave up is negative 2 to 1 and 1 to infinity, okay? Do you have any inflection point? Yes, we have, okay? Inflection point is at x equal to negative 2. That's it.